we're going to look at examples involving the inference about two means independent samples. So once again, we have requirements. The samples are obtained by simple random sampling or data that comes from a randomized experiment. Sample data are independent. Population are normally distributed, or the sample sizes are at least 30. Sample size is no more than 5% of the population. Notice now we're going to use the symbol for population mean, mu1. So mu1 equal mu2. Or mu1 is not equal to, greater than, or less than. We're going to do a 2-sample t-test, which is number 4 in the graphing calculator. And for pooled, we're going to select no. So the default is going to be no. For a sample of 1,657 men, age 65 to 74, their mean weight is 164 pounds. Standard deviation is 27 pounds. For a sample of 804 men, ages 25 to 34, the mean weight is 176. Standard deviation is 35 pounds. Test a claim that older men have a lower mean weight than younger men. Okay, so we're going to have older and younger. And we're looking at X bar. Remember, that's your sample mean. S and N. X bar, S and N. And we need to label these 1 and 2. 1 and 2. And again, you'll find this in your data. So let's see, we had 1,657 older men. Weight, sample or average mean weight was 164. Standard deviation was 27 pounds. The younger men, there's 804. The mean weight is 176. Standard deviation is 35 pounds. Remember, your null is always equal. Mu1 equal mu2. Test the claim that the older men have a lower rate. So mu1 is less than mu2 at the alpha equal 0.01 level. So once we get our test statistic, we get negative 8.56. Our p-value is 0. So 0 is definitely less than 0.01. We'll reject. There is sufficient evidence. Evidence to support the claim. That mu1 is less than mu2. Or we could say that older men have a lower mean weight than younger men. A study of zinc-deficient mothers was conducted to determine whether zinc supplementation during pregnancy results in babies with increased weight at birth. Is there sufficient evidence at alpha equal 0.05 to support the claim that zinc supplementation does result in increased birth weight? So here, this will be your mu1, this will be your mu2. So again, mu1 equals mu2. Mu1 is greater than mu2. At the alpha equal to 0.05. T value is 2.17. P value is 0.015. So let's see. So how does 0.015 compare to 0.05? It's definitely less than. So we're going to reject HO. There is sufficient evidence to support the claim. That zinc supplementation does result in increased birth weight. Okay, so again, we can look at an interval. So, a randomized trial tested the effectiveness of diets on adults. Among 40 subjects using the Weight Watchers, the mean weight was 3 pounds, with a standard deviation of 4.9. Among 40 subjects using Atkins diet, mean weight loss after 1 year was 2.1 pounds, standard deviation of 4.8. Construct a confidence interval, 95%, to estimate the difference between the population means. Does there appear to be a significant difference in the effectiveness of the two diets? So we'll start with alpha is equal to 0.95. Then we have Weight Watchers and we have Atkins. So what we need to know is we need N. So we need X1, S1, N1. That's X bar. X bar, S2, and N2. So we had 40 in both of the diets, both of the samples. S1 was 4.9, average weight loss was 3. Atkins, your average weight loss was 2.1 pounds. Standard deviation was 4.8. Okay, so our confidence level is equal to, not alpha, this should be confidence level, is 0.95. Alpha would be, if we want to know alpha, alpha is equal to 1 minus the confidence level. So alpha would be to 0.05. Okay. So we do this on the graphing calculator and we get negative 1.259. 3.059. Notice again, zeros in there where you have a negative and positive. Okay, so we're looking at negative, positive, referring back to what we saw in the previous lesson. There is no significant difference. Have a great day.